Swayam Prabha. Digital India. Educated India.
Welcome to the course Environmental Impact Assessment. Today we are going to cover methods used for air quality estimation within the larger ambit of EIA methods. We will cover this topic in two parts. Today we will see part 1. As you may recollect, our very first week of the lecture where we saw the environment status and looked at air in our environment. We saw that emissions generated by human activities is changing the composition of the Earth's atmosphere with the consequences for health of people and the planet. And it is estimated that the global burden of disease contributed by air pollutions have doubled. We saw that we changed the atmosphere mainly by generating emissions. We saw the drivers of these changes include, we have already seen this, these are population, urbanization, economic activity, technology and climate. As well as the drivers also include the behavioral choices we make, including lifestyle and the conflict we create. All these drivers are influenced by policies as well as to what actions we take or how we respond to these situations as a nation through policy interventions. So all these influence our environment. We also saw human activities that generate emissions from energy, transportation, industries, waste management and so on. Like you can see in the image here, various sectors which contribute to the greenhouse gas emissions. Every time a development comes, there is more like requirement for energy production, there's requirement for more transportation, more industries to come up, and we have to undertake assessment of what kind of impact it will have. We may know that a proposed development may change the concentration of pollutants in the atmosphere from the baseline situation, whatever is the situation at this moment, and would affect people, plants, animals, materials and buildings. These effects can occur at various levels. It can occur at local level, regional as well as at the global scale. Most of these developments have pollution problem. So as you can think upon, transportation, industries, all these have pollution problem. Many developments such as commercial or residential areas coming in the fringes also result in additional vehicle emissions as people travel to use them. So all the urban development which takes place also leads to more and more emissions. Many activities during construction period cause pollution. Also, you may see open cast mines, quarries. The potential exists for dust generation during the entire life cycle of the development. So not only at the construction period, but during the entire life cycle of this particular activity, the dust will be generated. And with it, the potential for contaminants such as heavy metals, silicates and other irritants which might be deposited in the surrounding areas. So you see how different activities influence the environment. Developments involving combustion may also give rise to both routine and non-routine pollutant emissions. You may also encounter a problem of odor. Any odor or smell can be offensive if it is continuous and intrusive, and therefore the potential effects of the release should be assessed carefully. So even that can be taken up in the assessment process. So for today, accordingly, our coverage will include We will look at the definitions and concepts. We'll cover air pollutants, human health. We'll look at both the aspects. We'll look at the air pollutants and the neutral and the built environment, and then we'll also look at orders. Further, we'll look into scoping and baseline studies. So, what kind of tools are there, while undertaking this, what all methods we adopt. So we'll look into pollution data availability, on-site pollution monitoring, projecting the baseline data, and so on. So the expected learning outcomes from you after completion of this session include that you should be able to explain various concepts, you should be able to define them in relation to air pollutants and then its impact on human health. You should be able to identify the air pollutants. Further, you should be able to identify or decide which methods to be used for scoping and baseline study purpose. So looking at the definitions and the concepts, air pollutants and its impact on human health. Air pollutants can affect the health of a person during inhalation and exhalation as the pollutants. These pollutants can cause inflammation, it can sensitize and even scar the airways, and can affect lungs in extreme conditions or and because of the long duration of exposure, they can have other impacts as well. And then pollution can reside permanent in the body. They can contaminate foods and drinks, and then impact can vary. The impact can be very simple like irritation, or it can be very serious like illness or even early death in some cases. So health effects depends upon the type and amount of pollutants present, the duration of exposure, and the state of health, age, and level of activity of the person exposed. So like we have been always seeing, the sensitivity of the receptor is also very important. Further, we see that various national and international organizations have identified levels of air pollution concentrations. So what the concentration should be, which should not exceed in order to protect human health. So we see that range of levels mentioned by different agencies, organizations on this. You may be also noticing that pollution damages the plants and animals caused by combination of physical and chemical stresses. So it's just not the human health, but it's also the health of the plants and animals around. They affect crops by causing leaf discolorization, reducing plant growth and yields, or by contaminating a crop, so making it unsafe to eat. They also affect terrestrial and aquatic ecosystem at local regional level. So you see those aquatic ecosystems, terrestrial and aquatic ecosystems are also affected by it. You may think of acid rain as well, and the surface of medium it falls on. So it also has other impacts, like there are a lot of monuments which are getting damaged by such kind of things. There can be nutrient imbalance due to deposition of nitrogen-based compounds such as ammonia on sensitive ecosystem. For example, we can see upland grasslands, sensitive water courses, and lakes or ancient woodlands. So all these are impacted by the imbalance in the nutrients. Such imbalance can compromise long-term survival of the habitat. So any kind of such changes happens, then it can really, in the long run, it can impact the sustainability of the habitat itself. The effect of air pollution on vegetation and ecosystem can be related to a pollutant concentration, which is also known as critical level. So you may note this critical level, which is the pollutant concentration level, or the deposition of the pollutant, which is also called as a critical load. So we are looking at the two terms here, critical level and critical load. Critical level is the pollutant concentration, critical load is the deposition of a pollutant. Critical levels, which is defined, they are the concentration of the pollutants in the atmosphere above which direct adverse effects on the receptors. So, anything above the critical level will have impact on the receptors, such as we could be the receptors, it could be the plants, it could be the ecosystem, or any kind of material wherever, like so far as we know about it. Critical level is the gaseous concentration of the pollutant in the air. So, you can learn about the two terms here. The critical load is the quantity of pollutant deposited from air to the ground. So, we see pollution's problem for buildings can be short term and reversible, such as soiling by smoke, which can be removed by cleaning. So, these can be handled, whereas the effects of acid deposition can be cumulative and irreversible by causing erosions and crumbling of the stone. So, there are certain that you need to look at whether these damages are reversible or irreversible. Now, looking at odors, odor, smell tend to be associated with mixture of chemicals that interact to produce what is detected as smell. Odor is an olfactory response, like you take it from nose, to a chemical or chemicals, and this is the key response of concern within an environmental and social impact assessments EIA process, and not the potential health effects of the chemicals themselves. So, not the chemical, but then how you absorb it through that passage. Smells are of concern, where these can lead to disamenity, annoyance, nuisance, or complaint. So, where people would complain about it, continuous exposure. So, there it's a problem. And we see that this can come from many sources and can have implication on the adjoining land use. So, when you deal with the land use, then there can be problem about what is adjoining to you and whether there is problem of odor in that. We see that odor, smell is a subjective to the individual and response can vary. So, it's a very subjective thing, odor and smell. Odor or smell, before an adverse effect can exist, individuals must experience exposure to odor. For odor exposure to occur, there must be an odor source. So, you see that there must be an odor source and a pathway which can connect the receptor to the source, and the scale of the exposure can be determined by reference to parameters. So, you see there are certain parameters known as FIDOL, which is frequency, intensity, duration, offensiveness, and location. So, these are the parameters through which you look at the exposure level. The first four of these factors, first four, that is frequency, intensity, duration, offensiveness, relate to the magnitude, like how much it is, or the scale of exposure, how much the individual is exposed, and then the latter, which is the location, relates to the sensitivity of a particular receptor population. So, who is on the receiving end. So, it's the last one you see is depends on the receptor. Now, moving on, let us briefly revisit ambient air quality guidelines and standards for human health. WHO, World Health Organization, provides values. So, it gives us values, reference values. The WHO guidelines values are based on health considerations alone. So, they only look at the health consideration for health perspective, what is important, what are the ranges which are of concern to us. And they do not consider the technical feasibility or the economical or political or social dimension of attaining those goals. So, WHO guidelines are completely focused on health consideration. You may know that air quality standards vary nationally around the world. So, you would see that the WHO is only based on the health considerations. So, based on the socio-economic and political conditions, you see that the standards, air quality standards, vary nationally around the world and is not strictly aligned with the WHO guidelines. We also see that International Finance Corporation IFC provides performance standards. So the standards are also given. It is an international benchmark for environmental and social risk management. Also the Environmental Health and Safety EHS guidelines are also available, which provide technical advice with general and industrial specific examples of good international industry practice GIIP to meet the specified performance standards. So they also provide guidelines for that. You can see the snip of that particular guidelines here. We also see that in Indian context, we have CPCB, which provides us the complete standard list. The link is also given to you to look further. So you see the National Ambient Air Quality Standard. We also see air quality guidelines and standards for vegetation and ecosystem. You may reflect and understand that effect of air pollution on vegetation and ecosystem is a relatively complex and evolved area that requires cooperation between air quality scientists and ecologists to properly assess the significance of the effects within the context of assessment framework. So it's a complex subject altogether, the theme to be looked into, and it needs interdisciplinary people to work on together. So critical load for deposition. So when we look at the vegetation, the critical load for deposition into sensitive ecosystem have been specified by UNECE, which is United Nations Economic Commission for Europe. So according to them, any exceedance of the critical load, so any or beyond this level of the critical load is used as an indication of potential for harmful effects to occur. So this is used as a cutoff line. Anything beyond this critical load is seen to be damaging for the environment. There's also UK Air Pollution Information System, which provides useful guide to critical loads and different levels. So you can see the example, the snip put out for you here. There are also other guidelines and standards. Several countries have developed and adopted legislation for measurement of odor, such as Australia, Belgium, Canada, Denmark, Germany, and so on. However, there are no internationally recognized standards for the assessment of odor, so we do not have international standards for this. One approach adopted in UK, which we can see here, involves measurement of odor, which is based on European Odor Unit, OUE, which you can see European Odor Unit. The definition of one OUE represents the threshold whereby 50% of the members of an order panel, so whichever is the panel, in that 50% of the members can detect an odor in the laboratory conditions. So when 50% people can detect that particular odor or smell, then it is like considered to be one unit. In India, Schedule 2 and Schedule 6 general standards for discharge of effluents under environmental protection rules 1986 prescribes that all efforts should be made to remove unpleasant odor as far as practicable. So further we looked at in terms of FIDOL parameters, FIDOL parameters, and odor concentration as the 98th percentile takes account of the frequency, intensity, and duration elements of the equation. So here you see that 98th percentile is taken care of here. For the location dimension, different concentration threshold may be applied to different land uses. So as per the land use, whatever is the land use, so you might be very sensitive about the restaurant or the industrial or the commercial location or the hospitals being there. So accordingly you may see that. Here in the image you can see the example of a map resulting from atmospheric dispersion simulation representing the ISO concentration lines corresponding to 98th percentile of odor concentration values of, like you can see, different values 1, 3 and 5 which are given here. We also see the Institute of Air Quality Management guidance. This is also provided. This institute provides suggested order effect descriptors. It gives certain descriptors which is based on the receptor sensitivity. So, our sensitivity to particular order and for ranges of predicted order concentrations. So, it gives us our sensitivity to the concentration of order. However, the practitioner is required. So, for this purpose, you would need practitioners to use professional judgment in choice of criteria and must be able to justify their choices. So, you can see here the Institute of Air Quality Management guidance here. There are very clear emission limits and standards in every country and may vary with location. So, we see that air quality standards refer to the levels of air pollution to which people and ecosystems are exposed. Another type of legislated standard is the emission standards, which specifies the maximum amount of concentration of pollutant that can be emitted from a given source. Emission standards are usually derived from consideration of the cost and effectiveness of the available control technology. So, every nation, depending on the technology available to them, they would be specifying the emission standards. Now, there is a lot of pressure on the reduction of the emissions. So, you have been reviewing all the ongoing activity at the global level. So, there is a lot of pressure on the reduction of the emissions, in particular with the climate change, what we are addressing urgently right now. And the emphasis is laid on the technology development and use of clean fuel. So, not only it's about the emission, controlling the emission, but the emphasis is also on improving the technology as well as using the clean fuel. You may refer to IFC environmental health and safety guidelines and good international industry practice. There are also regulations for hazardous chemicals. So, in the case of proposed development, so whatever development is coming that involves materials that could be harmful to people in the event of an accident, the assessment should include an indication of the preventive measures to be adopted. So, what kind of preventions you are going to adopt so that such an occurrence is not likely to have a significant effect. So, you need to look at all the probable accidents which can happen, what kind of waste would be generated. You may also refer to CPCB website, and the link is also provided to you for the purpose for the regulation of hazardous chemicals. So, these are some basic concepts. So, these were some basic concepts which we looked at. Now, moving on, let us look at method for scoping and baseline studies. There are very stringent laws and guidelines in every country for air quality. So, air quality you may see and you must have experienced. Now, there is very strict laws while you drive your car and while industries are set up. So, during scoping stage, air quality impacts should be considered in the EIA process after thorough discussion with the regulatory authorities. Then you should really take them, you should have discussion with the regulatory authorities. Based on that, you would be able to decide which pollutants to consider and which not to consider, and whether you will need to address order impact. So, once you look at the regulations, you will know what are the parameters to be covered and whether the smell aspect has to be taken or not. Also, depending upon the development project, whichever project you are dealing with, many atmospheric pollutants may be considered for the assessment purpose. It could be nitrogen oxide, sulfur dioxide and so on. So, the list is usually given in the framework. And then also you may look at there must be also gases, greenhouse gases, which you might have to consider given the climate change and our international agreements on those. Further, you may also consider other pollutants which may harm the health as given by WHO guidelines. While undertaking scoping process in EIA, you need to understand that a particular atmospheric pollutant will depend on the nature and scale of the development. It will depend upon the sensitivity of receiving environment and the baseline conditions. So, the receiving environment, how sensitive, what is the sensitivity, what's the range of that particular environment to receive that pollutant, and what is the already existing condition, which we look in the baseline condition, and also on likely changes that may occur in relation to this. So what kind of changes when your development comes, what kind of changes will happen because of this in the baseline condition, and then also you look at the sensitivity of the receiving environment. You should also essentially check if the baseline condition of an area under study would change irrespective of the proposed development. So whether your development happens or not happen, but then you should check whether those the baseline condition would in its own is going to change or not. So that's important to check. So you might keep a check whether it might reach to a higher level, threshold level, where your things might change. It is important to know because if the area is already under stress, any increase in amount will exceed the permission level. So you need to be careful about that. In the projects which are less likely to have impact on air quality and therefore are removed from the scope, there also accidental consideration should be taken. So whenever you are not really, it's not coming under the scope, but then accidental consideration should be taken in such cases. Also, you must take note of any sensitive uses such as hospital, houses, industrial premises, ecological sensitive sites, and so on in and around the site of the study. So you need to be very cautious about the adjoining land use, land cover, what is there. You may encounter issues of odor from sewage treatment work, chemical plants, paint work, food processing factories, brickworks, and commercial kitchens. So all these you can have these odor issue as well. Odor often generate great annoyance, so there might be a lot of complaints from the occupants around when residents are subject to them and even their surrounding areas. So now looking at the pollution data availability. So from where do you really get these data? So it is advisable to undertake desk study. So the first step, what we do is to undertake desk study before the impact study is undertaken for the proposed development. So you can obtain baseline data from existing pollution monitor. You may require data from one or more locations in study area to assess the amount of pollutant present. So you might choose a specific location to collect data. In many countries, national or local monitoring network exists. So there are already networks which are there which monitor air quality data, and monitoring may also be undertaken by universities and organizations. So there are a lot of universities and organizations which regularly monitor and maintain data. So you can also retrieve from them. Most of the pollutant data from national network are often freely available online, so you can use them as well. For example, the Central Pollution Control Board in India. Then you have automatic urban and rural network in UK. Then you also see US air quality system, or you can also look at World Air Quality Index, or they can be requested from relevant authorities. So you can ask for data if they are not available freely online. So you can take information from them. Further, one is you can do the desktop, other is you can take on-site pollution data by monitoring. If you observe that the pollution data are not available or are insufficient, then you can undertake on-site baseline monitoring as per your requirement for the particular project. Data collected should be planned, so you need to plan well ahead of time and initiate it during the scoping phase itself. So you need to decide it in the scoping phase, and you should look at what pollutants to monitor, which all pollutants. So this you'll be also checking through your regulatory framework, what type of monitoring equipment to employ. So what kind of equipment will be employed, the number and location of sampling sites, this duration of survey, the time resolution of sampling, and so on. So that all needs to be decided beforehand. You may select the equipment to measure air pollution concentration based on the intended use of the data. So how you're going to use it, how you're going to analyze it, and you also need to look at the budget allocation for the purpose, how much money you have, and whether you need to hire equipments or you can purchase the equipments, and so on. The expertise of personnel available. So you have people who can take care of the collection and processing of these data, information which you gather. So that all you have to look at. Certain measurements can be expensive, and hiring options are also available, so you can look at those. Be aware of suitability of the equipment for the purpose and comparability with these standards. So once you look at these standards and once you choose the equipments, you look at the output of the data and you see that whether that goes along with what you are required to report as per these standards. So you might also make necessary consideration for the need to protect against vandalism. So you need to also take care of those. Access to the site, whether you'll be able to take it to the site or not. The avoidance of pollution from indoor and localized sources, which may make the data unrepresentative of the wider area. The availability of power supply. So all these aspects also need to be taken care of when you implement or you put certain equipments in place. If you are using the data for modeling, you should locate them in location which avoid deflection. So you also need to select your site for locating equipment also very carefully, and it should be mostly placed very close to the point of interest where you want the data to be collected from. So you can see here the passive diffusion tubes, how they have been fixed for data collection purpose. Now looking at the duration of baseline monitoring for the assessment purpose, that will depend upon the pollutant to be tested. So which pollutant you want to test and the standard which is to be assessed, for which you have to follow. Pollution concentration vary from hour to hour, so the concentration would also vary. It will also vary from day to day and month to month, and is influenced by a range of external variables such as wind, speed and direction, sunlight, temperature, precipitation, humidity, and so on. So you need to be careful about that. And as a result, monitoring for a short period of time is unlikely to provide satisfactory indication of baseline condition. So short period data might not be very desirable. What is suggested is a minimum monitoring period of 3 months. So you should monitor your data for 3 months, and to 6 months is most preferred one. Plus you would also note that CPCB also gives you guidelines on the duration for which the data has to be collected. Then you also look at the pollution bioindicators, like types of plants that are sensitive to pollutant levels. So you can also, this is very good way of checking it as well. So you can look at certain plants. They also provide supplementary information on pollution levels. Soil and vegetation analysis can also provide long-term level of pollution such as metals, and also by seeing them also you can understand the pollution level. If data is not available on a particular order source, so now looking at like order per se, then if the data is not available for particular order source, it may be necessary to undertake sampling and chemical analysis in order to determine an appropriate order source term. For industrial installation, this requires the cooperation of operator and may not always be possible. So you also need to look at that. So you also have generic order emission factors which exist for certain type of industrial process such as sewage treatment work. So those are readily available which you can use. And such generic emission factors must be treated with caution when being used to model specific scenarios. So you can also model it and you can take it as an input data. And then you can project the baseline using these information. So looking at the projecting the baseline information after establishing baseline pollutants levels. So now you have collected the data, you may have to consider how these levels are expected to change. So now you're going to predict like what kind of changes would come in future with the proposed development and without the proposed development. So if emission sources and strengths are not expected to change, then current pollution levels may be considered to be representative of the pollution level in near future. So if you see in the simulation model that the values are not changing, then you can take the current